In the endless dark between stars, where the vacuum holds secrets older than human memory, something happened that wasn't supposed to happen. A whisper crossed the void. A pattern emerged where randomness should reign. A question was asked in a language we almost understood. December 19th. Remember this date. Commit it to memory. Let it settle into the quiet places of your mind where doubts gather like dust in forgotten corners. For on this unremarkable day, this arbitrary division of time on a small blue world circling an ordinary star, the universe revealed something about itself. Not with fanfare or celestial pronouncement, but with the faintest deviation in expected values, with data points that refused to align, with a signal so subtle that it could have been missed entirely if someone hadn't been watching with impossible patience. And perhaps this is the most unsettling truth of all. Not that the answer remains hidden, but that the silence following the signal feels deliberate, feels weighted with intention. As though the cosmos itself has inhaled and now holds its breath, waiting to see what we might do with this fragment of knowledge that refuses to resolve into clarity. Waiting to see how we handle the unbearable tension of data that simultaneously points in contradictory directions. Waiting to judge whether we deserve further revelation or if this half-glimpsed truth is all our limited minds can bear. In climate-controlled rooms that hum with the quiet breathing of machines designed to extend human perception beyond biological limits, researchers continue their work. Their faces illuminated by screens that cast unnatural light across furrowed brows, they exist in a twilight realm between knowing and not knowing, a purgatory of unresolved mystery that has become both torment and addiction. They analyze streams of numbers that represent light gathered from impossibly distant objects, filtering signal from noise through algorithms that grow more sophisticated with each iteration, each refinement seeking patterns too subtle for intuition alone to grasp. Their fingers move across keyboards, making minute adjustments to models that attempt to capture behavior that defies expectation, that refuses to conform to frameworks built from our limited experience with objects that formed within our solar system's particular conditions. They work in shifts that blur into one another, passing observations and theories between time zones as Earth rotates beneath the indifferent stars, maintaining a continuous vigil as though afraid that blinking might mean missing the moment when the pattern finally reveals its meaning. When they publish their findings, these papers emerge into the world clothed in the careful, measured language of science. Precise words chosen with surgical care to convey exactly how much is known and how much remains in shadow. To an outside reader, phrases like anomalous deviation from predicted values or unexplained variance requiring further investigation might seem unnecessarily cautious, might be dismissed as academic hedging. But those who understand the weight these words carry recognize them as something else entirely. The reluctant admission that nature has revealed something we cannot yet fully grasp, something that dances at the edges of current understanding, something that hints at deeper complexities than our models have accounted for. These researchers know something the public does not, that premature certainty is the poison that kills true discovery, that conclusions declared too confidently become cages from which evidence must later be painfully freed, that reputations built on interpretations later proven incomplete can collapse with devastating speed. They have witnessed careers implode when cherished theories met contradictory data. They have seen decades of understanding distorted by frameworks that calcified too quickly around partial truths. And so they choose their words with extraordinary care, building sentence structures that can hold uncertainty without breaking, that can contain multiple interpretations simultaneously, that can acknowledge the provisional nature of all human knowledge without surrendering to complete relativism. As months pass, the professional literature begins to reflect something resembling consensus, a fragile agreement about which interpretation better explains the totality of evidence gathered since December 19th. But this consensus is not the solid foundation laypeople might imagine scientific certainty to be. It is instead a delicate latticework of qualified statements, a carefully balanced architecture of evidence weighted by reliability, a structure whose blueprints explicitly include spaces for revision and reconsideration. Every conclusion comes hedged with caveats. Every model acknowledges its limitations. Every explanation carries footnotes detailing alternate possibilities that cannot yet be eliminated. Minority positions persist at the edges of this tentative consensus, maintained by researchers who see patterns in the data that the majority interpretation doesn't adequately address. Their papers continue to appear in respected journals, presenting evidence that cannot be easily dismissed, offering theoretical frameworks that account for anomalies the mainstream view struggles to explain. These dissenting voices aren't silenced or excommunicated as might happen in fields less committed to evidence above authority. Instead, their alternative interpretations remain acknowledged possibilities, minority reports that could, with additional evidence, expand to become the new consensus. In review articles that attempt to capture the state of knowledge, discussions of remaining ambiguities fill entire sections. These aren't brief acknowledgments of minor uncertainties but detailed explorations of the specific ways in which current understanding remains incomplete. Data limitations are cataloged with cartographic precision, mapped like unexplored territories on ancient charts where sea monsters might dwell. Areas where measurement precision falls below what would be needed for definitive conclusions are marked clearly. Points where different lines of evidence appear to contradict each other are highlighted rather than obscured, treated as valuable signposts pointing toward deeper understanding rather than embarrassing inconsistencies to be minimized. This mapping of ignorance, this precise delineation of what is not known, represents not failure but integrity. It is science operating as it must in a universe that does not organize itself for human convenience, that does not provide data in neat packages aligned with current theoretical frameworks, that does not ensure ideal observation conditions for phenomena of interest. It is the honest response to a reality where evidence arrives imperfect and incomplete, where crucial measurements may be impossible to obtain, where objects under study do not pause their motion through space to allow more detailed examination, where nature maintains its absolute right to be more complex, more layered, more resistant to categorical thinking than our models predict or our minds prefer. The silence that followed December 19th's signal carries its own distinct gravity, a weight made of absence, a presence defined by what is missing. Like a black hole detected only through its effect on surrounding objects, this silence bends thought around itself, distorting expectation, creating a curvature in understanding that cannot be navigated by conventional means. We feel its pull without being able to directly observe its nature. We orbit around the question it creates without approaching resolution. Our minds, conditioned by evolutionary pressures that reward quick pattern recognition and decisive action, struggle against this sustained uncertainty. Our narrative instincts, shaped by stories that build tension toward climactic resolution, rebel against the refusal of mystery to collapse into explanation. We expected, at some fundamental level beyond conscious thought, that December 19th would eventually surrender its secrets, that the initial confusion would clarify into understanding within some reasonable time frame that aligned with human patience and attention spans. We anticipated the satisfying convergence of competing hypotheses toward a single compelling explanation that would retroactively make sense of all observed anomalies, that would transform bewilderment into the pleasure of comprehension, that would convert the discomfort of not knowing into the stability of established knowledge. But the universe does not construct its mysteries according to human storytelling conventions. It does not build narrative tension with the intent to release it at emotionally satisfying moments. It does not ensure that questions raised will find answers within time frames that match our lifespans or our funding cycles or our publishing schedules. It operates according to principles utterly indifferent to whether human observers find its behaviors comprehensible or meaningful or aesthetically pleasing. The timeline of cosmic processes stretches across billions of years. The scale of space encompasses distances so vast that light itself, the fastest thing we know, requires millions of years to cross them. Against such scales, human expectations about how quickly mysteries should resolve appear not merely optimistic but absurdly presumptuous, like bacteria expecting to comprehend the architecture of the building they inhabit. The continuation of uncertainty beyond the point where narrative logic suggests resolution should occur may ultimately teach more profound lessons than any definitive answer could have provided, though these lessons offer no cathartic release, no moment of triumphant discovery, no opportunity for simplified headlines announcing that science has solved the mystery of December 19th. Instead, they teach a form of patience that contradicts our deepest instincts. Patience not as passive waiting but as active engagement with persistent ambiguity, as sustained attention to phenomena that refuse to yield simple explanations, as the discipline to continue asking questions when easy answers remain elusive. This patience must be deliberately cultivated against powerful evolutionary and cultural currents pushing toward premature closure. Our brains, evolved to make quick decisions based on limited information in environments where hesitation could mean death, constantly urge us toward conclusion even when evidence remains insufficient. Our academic institutions, structured around publication metrics and tenure reviews and grant cycles, reward definitive statements more readily than careful explorations of persistent mysteries. Our media ecosystems, optimized for capturing fleeting attention rather than sustaining deep engagement, favor stories with clear resolutions over open-ended investigations. Against all these pressures, the researchers studying December 19th must maintain a discipline of uncertainty, must resist the constant temptation to declare the mystery solved before it truly is, must endure the psychological discomfort of not knowing when every instinct cries out for the security of definitive explanation. This discipline extends beyond mere intellectual honesty to encompass a deeper form of humility, not the performative kind that costs nothing and serves mainly to signal virtue, but the genuine, uncomfortable recognition that our frameworks for understanding the cosmos may be fundamentally inadequate in ways we cannot yet perceive. This humility acknowledges that the universe operates according to principles that existed for billions of years before human consciousness emerged and will continue long after our species has vanished. It accepts that these principles owe us no obligation to be comprehensible on our preferred timescales, to conform to our existing categories of thought, to reveal themselves through the particular observational tools we happen to have developed. It recognizes that what appears as mystery may reflect not just temporary gaps in knowledge that additional data will easily fill, but deeper limitations in human cognitive architecture itself, limitations that might require entirely new conceptual frameworks to overcome, if they can be overcome at all. December 19th forces us to confront the uncomfortable possibility that understanding advances not through the dramatic revelations our cultural narratives have conditioned us to expect, but through processes so gradual they become visible only when viewed across generational timescales. Despite the stories we tell about eureka moments and paradigm shifts occurring in blinding flashes of insight, despite our celebration of individual genius making conceptual leaps that transform understanding overnight, the reality of scientific progress may be far less cinematically satisfying. It may instead resemble the patient accumulation of coral building a reef, each researcher adding small contributions that seem insignificant in isolation, each generation extending structures begun by ancestors they never knew, patterns emerging so slowly that no single observer lives long enough to see their completion. This truth proves difficult to communicate to those outside the process, to publics conditioned to expect dramatic discoveries announced in triumphant press releases, to funding agencies that want demonstrable returns on investment within predictable timeframes, to students considering careers in fields where the most significant questions might remain unresolved for decades. It requires a perspective that few cultures encourage, an acceptance that the most important work of understanding might unfold across time frames where individual contributions become visible only in retrospect, where the most crucial insights emerge not from single brilliant minds but from the collective efforts of communities extending through time, where the questions raised by December 19th might find resolution only after those who first observed its anomalies have completed their careers, and perhaps their lives. Yet regardless of whether consensus ever fully forms around what happened on December 19th, regardless of whether researchers eventually feel confident declaring one explanation correct and alternatives abandoned, the date itself has already transformed how future interstellar objects will be studied. The mere recognition that something subtle yet potentially significant occurred on a timeline that surprised researchers, that emerged under conditions they had not specifically predicted would be important, has changed the infrastructure of attention in ways that will persist for decades. How we watch has been permanently altered. The very architecture of observation, from instrument design to scheduling protocols to data analysis methodologies, has shifted to accommodate the possibility that interstellar objects might harbor complexities that reveal themselves only under specific conditions we cannot predict in advance. Observation campaigns for future interstellar visitors will be structured differently because of December 19th, designed with the knowledge that these objects can hide their complexity until particular combinations of circumstances are met. Instruments will maintain vigilance through phases of apparent inactivity, sustaining detailed observation during periods when previous models would have predicted nothing of interest, refusing to assume that initial quiescence implies permanent predictability. The cost of December 19th's partial answers, the tantalizing glimpse of pattern without complete revelation, has taught the painful lesson of looking away too soon, of assuming understanding before sufficient data has accumulated, of allocating observational resources elsewhere just before the moment when anomalies might have revealed themselves more clearly. Future observation schedules will cast wider nets through parameter space, capturing data across broader ranges of solar distances and viewing geometries, recognizing that interesting phenomena might manifest only within narrow windows of conditions that cannot be predicted from limited experience with small sample sizes. The universe might choose to speak only when specific combinations of angle and distance and solar activity and observation wavelength align in patterns we cannot anticipate in advance, when circumstances converge to create briefly visible effects that disappear as quickly as they emerged. Detection systems will be designed with greater sensitivity to smaller deviations, with faster response times to potential anomalies, with better filtering algorithms to distinguish genuine signals from instrumental artifacts, with global coordination protocols to ensure confirmation from multiple independent facilities before transient phenomena fade below detection thresholds. Speed acquires particular importance when studying objects moving at interstellar velocities, when windows of opportunity close with the mathematical inevitability of orbits that care nothing for human readiness or human curiosity. When an object traverses the inner solar system in months rather than years, when each passing day carries it farther from optimal observation range, when detection capabilities degrade as inverse square laws reduce signal strength below what even the most sensitive instruments can capture, response time becomes critical. A delay of hours can mean missing the opportunity to gather specific measurements. A delay of days can mean losing the ability to detect certain phenomena entirely. A delay of weeks can mean watching helplessly as the object recedes beyond the reach of detailed study, carrying whatever secrets it might have revealed into interstellar darkness where they become forever inaccessible to current technology. Theoretical work will expand in parallel with observational capabilities, deliberately exploring regions of parameter space previously dismissed as unlikely or unimportant, incorporating wider variation in assumed composition and structure, investigating formation scenarios that produce objects with delayed or conditional responses to solar heating, considering evolutionary pathways that might create materials and configurations not represented among local solar system objects. Models will extend beyond the comfortable middle ground where familiar objects cluster, beyond the parameter ranges calibrated to explain the behavior of comets and asteroids that formed within our star's particular nebula, that experienced our specific history of stellar evolution, that underwent processing determined by their position within our unique arrangement of planetary orbits and radiation environments. These expanded theoretical frameworks acknowledge that visitors from other stellar systems may represent fundamentally different starting conditions, may have been shaped by processes that have no direct analogs in our local experience, may contain materials and combinations or states that are rare or absent among objects formed in our solar system. They recognize that when studying samples from a population of potentially hundreds of billions of objects formed around tens of billions of stars, with formation histories stretching across the galaxy's entire existence, the assumption that the first few examples observed will conveniently resemble familiar categories represents not scientific conservatism but failure of statistical reasoning and imagination. The practical changes inspired by December 19 ripple outward through the entire infrastructure of interstellar object observation and study, creating wavefronts that will be felt in funding decisions, career specializations, instrument design priorities, and international coordination protocols for decades. Telescope time proposals now request longer continuous observation periods for newly discovered interstellar objects, must justify why sustained attention to a single target is worth the opportunity cost of other observations competing for limited access to our most capable instruments both on Earth and in orbit. These justifications become exercises in articulating the potential value of phenomena that may never reveal themselves, in quantifying the worth of patience that may never be rewarded with discovery, in balancing the certain cost of dedicated observation against uncertain benefits that cannot be predicted in advance. Funding agencies face parallel challenges when evaluating whether expanded monitoring programs justify their expense given the still small sample size of detected interstellar objects, when weighing guaranteed costs against speculative returns, when trying to predict whether the next interstellar visitor will justify investments in systems designed to capture phenomena like those that December 19 only partially revealed. These decisions involve not just technical assessments of instrument capabilities and detection probabilities but deeper questions about the value of knowledge itself, about whether understanding the nature of objects from beyond our solar system represents sufficient intrinsic worth to justify significant resource allocation even without guarantees of dramatic discovery, about whether patience in the face of cosmic timescales deserves support despite its poor alignment with budget cycles, and political attention spans, about what price we're willing to pay for the chance to glimpse truths that might transform our understanding of humanity's place in the wider universe. International coordination networks face their own challenges in developing new protocols for rapid information sharing when studying transient phenomena associated with objects that move through optimal observation range within months. These protocols must enable confirmation of potential discoveries before objects recede beyond the range where detailed study remains practical, must facilitate global response to anomalies detected by individual facilities, must ensure that interesting phenomena don't disappear back into interstellar darkness carrying their secrets with them before enough evidence has accumulated to determine their nature. They must overcome institutional rivalries, navigate complex intellectual property considerations, bridge language barriers and time zone differences, coordinate resources distributed across political boundaries that celestial objects cross without acknowledgement or pause. These consequences of December 19th will never generate headlines or inspire documentaries. They involve infrastructure changes too technical and gradual to capture public imagination, shifts in resource allocation too incremental to notice unless viewed across years rather than days, evolutions in analytical methodology too specialized for non-experts to fully appreciate. Yet they shape what becomes possible for future discovery in ways far more profound than any single observation ever could. They determine whether the next object that behaves in unexpected ways gets detected early enough for coordinated global response or whether interesting phenomena get noticed only in retrospect, when it's too late to gather crucial additional data, when researchers can only reconstruct what might have happened from incomplete archives while wishing desperately for measurements never taken because no one was watching carefully enough at the right moment. In this capacity, December 19th functions as a lesson the universe will offer again, as many times as necessary, with the infinite patience of something that operates on timescales where human lifetimes barely register as measurable units, where civilizations rise and fall in periods equivalent to brief molecular vibrations, where stars complete their life cycles in what would constitute mere moments if cosmic history were compressed to human scale. The universe will continue sending objects through our stellar neighborhood whether or not we're paying attention, whether or not we're equipped to recognize their significance, whether or not we've developed observational systems sophisticated enough to capture their subtle behaviors. It will repeat the experiment with new variables, new initial conditions, new objects following different trajectories through different regions of the solar system, until humanity develops the capacity to catch ephemeral signals in real time rather than reconstructing them from imperfect archives months later while wondering what might have been missed. Looking forward into futures we cannot yet see clearly, the question is not whether another interstellar object will surprise us with unexpected behavior. That outcome is inevitable given the statistical certainty that our limited experience with the first few detected examples cannot possibly encompass the full range of properties such objects might possess. The galaxy contains hundreds of billions of potential sources for interstellar objects, each representing slightly different formation conditions, different stellar environments, different histories of processing and transformation during journeys that might have lasted millions or hundreds of millions of years before intersecting our particular solar system at this particular moment in its history. The combinatorial explosion of possible variations ensures that surprises await discovery, that future objects will reveal properties and behaviors not predicted by models built on limited samples, that the catalog of known interstellar object characteristics will continue expanding for as long as humanity maintains its vigilance of the skies. The real question, the one that matters for the future of this emerging field, is whether we will be watching carefully enough when the next surprise occurs, with sufficient instruments and theoretical frameworks and coordination protocols to recognize the significance of anomalies while they're still happening rather than only after they've passed. Whether we'll be positioned to respond before the opportunity vanishes, before the object recedes into distances that make detailed study impossible, before we find ourselves once again with partial data and questions that may remain unresolved for years or decades. The universe will not slow its operations to accommodate our learning curve, will not pause the motion of objects through space to give us time to build better instruments or develop more sophisticated theories or establish more effective response systems. It will continue sending visitors through our cosmic neighborhood at its own pace, following dynamics established billions of years ago, operating according to physics that remains utterly indifferent to whether humans have developed the observational tools and theoretical frameworks needed to understand what they're seeing. All we can do in response is build better systems, maintain vigilance across generations of researchers, and accept, truly accept, not just intellectually acknowledge, that some questions raised by December 19th may remain suspended in uncertainty for years or decades or longer. They may find resolution only after enough additional examples have accumulated to reveal patterns we cannot yet perceive because our sample size remains counted in single digits, our observational record spans less than a decade, our theoretical frameworks derive from experience with objects formed under conditions specific to a single stellar system among billions. This acceptance of extended uncertainty proves harder than it might initially appear. Human minds crave closure. We want questions answered definitively, mysteries resolved completely, ambiguity replaced with clear knowledge. We experience discomfort when confronted with problems that resist quick solution, with phenomena that cannot be easily categorized, with evidence that points simultaneously in multiple directions. Learning to work productively within sustained uncertainty, to make progress without demanding final answers, to hold contradictory possibilities in mind without premature commitment to any single explanation, represents a discipline that goes against deep psychological grain. It requires constant effort to resist the tendency toward confirmation bias, to avoid selectively perceiving evidence that supports preferred hypotheses while dismissing contradictory data, to maintain openness to alternative interpretations even after investing significant intellectual and professional capital in particular frameworks. This discipline becomes especially challenging when studying phenomena that operate on cosmic rather than human timescales, when the answers to questions raised today might emerge only after current researchers have concluded their careers, when the payoff for careful observation and theoretical restraint might manifest only for future generations. Yet beneath all the technical debates about thermal processes versus structural complexity, beneath discussions of observation protocols and funding priorities and instrument design specifications, December 19th poses questions that transcend the purely scientific to touch on fundamental philosophical issues. Questions about the nature of knowledge itself and what it means to truly understand something as opposed to merely modeling its behavior. Why do we expect the universe to behave simply, to organize itself into categories that align conveniently with human cognitive capacities? Why does deviation from prediction disturb us at such a profound level, creating discomfort that extends beyond intellectual puzzlement into something closer to existential unease? Why do we experience almost visceral resistance to acknowledging that our models might require fundamental rather than incremental revision, even when we intellectually understand that those models are necessarily incomplete, built on limited data, constructed with cognitive architectures that evolved to solve very different problems than understanding cosmic processes? The answer touches on something fundamental about how minds work, about the basic architecture of consciousness that allowed our species to survive long enough to begin asking questions about interstellar objects in the first place. We navigate reality not by processing its infinite complexity directly, an impossible task for finite brains, but by building simplified models that capture enough relevant features to enable prediction and decision-making. We construct mental frameworks that categorize and classify, that identify patterns amid noise, that reduce the overwhelming variety of sensory input to manageable abstractions we can manipulate and reason about. Categories become essential cognitive tools, mechanisms for compressing infinite variation into finite representational spaces, for making sense of a reality too complex to comprehend in its raw, unfiltered state. These simplified models serve us well under most circumstances, allowing navigation through environments where perfect understanding isn't necessary for survival, where approximation provides sufficient guidance for effective action, where close enough proves good enough for evolutionary success. But this same cognitive architecture, this same capacity for building simplified models of complex reality, contains inherent limitations when applied to phenomena operating at scales or complexities far beyond those our brains evolved to handle. When confronted with objects that travel between stars, with processes that unfold across millions of years, with physical conditions unlike anything in our direct experience, our intuitive modeling capacities may produce frameworks that systematically misrepresent crucial aspects of reality, that fail to capture emergent behaviors that appear only under specific conditions. that impose familiar categories on phenomena that actually represent entirely different organizing principles. When reality refuses to conform neatly to these models, when objects behave in ways our frameworks failed to anticipate, when the universe demonstrates that our simplified representations have missed something essential, the resulting discomfort extends beyond mere intellectual adjustment to touch something closer to identity itself. It feels like threat, like the ground becoming unstable beneath our feet, because it suggests our understanding of reality, the very basis on which we construct meaning and navigate existence, might be fundamentally flawed in ways we hadn't recognized, might contain critical errors rather than minor imprecisions, might need replacement rather than simple refinement. This recognition threatens not just specific theories but our confidence in the reliability of the cognitive tools we use to construct those theories, creating a recursive uncertainty that can feel vertigo-inducing in its implications. This discomfort proves difficult to articulate fully but impossible to ignore completely, the nagging sense that December 19th revealed not just limitations in specific models of interstellar object behavior but hints of deeper inadequacies in our approach to understanding cosmic phenomena more generally. Yet paradoxically, this very discomfort represents perhaps the most intellectually valuable aspect of the entire scientific enterprise. If reality always conformed to our expectations, always behaved exactly as our theories predicted, always fit neatly into the categories we constructed to contain it, we would never discover that our models needed revision, would never have reason to expand our conceptual frameworks, would never confront the humbling truth that the universe contains depths and complexities beyond what any human mind will ever fully comprehend, no matter how sophisticated our mathematics becomes, no matter how sensitive our instruments grow, no matter how many generations of researchers build upon previous understanding. Viewed through this philosophical lens, December 19th represents not a problem to be solved but an opportunity to be embraced, not a failure of prediction but an invitation to grow our understanding in directions we had not anticipated, into territories that don't yet have names or maps or established methods of investigation. It reminds us that genuine discovery involves not just finding things where and when we expect them but recognizing significance in phenomena that appear where theory suggested nothing important should exist, that manifest under conditions previously considered unremarkable, that behave according to principles not yet incorporated into standard models. It suggests that the most valuable observations might be those that don't make immediate sense within established frameworks, that resist easy categorization, that force reconsideration of assumptions so deeply embedded in current thinking they had become effectively invisible until challenged by anomalous data. The question beneath the question, the one that keeps some researchers awake in the deep hours when professional confidence temporarily recedes and doubt seeps in through the cracks, is whether we possess both the necessary discipline to build rigorous, testable models and the intellectual flexibility to recognize when those models require fundamental rather than incremental revision. This balance proves exceptionally difficult to maintain because human psychology desperately wants certainty, craves the feeling that hard-won knowledge represents permanent achievement rather than provisional understanding subject to future revision or even replacement. We invest years in mastering theoretical frameworks, in developing specialized expertise, in building professional identities around particular approaches to understanding how things work. These investments create attachment that extends beyond intellectual commitment into something closer to emotional identification with specific models, frameworks, and interpretations. This attachment generates inevitable resistance when evidence suggests that foundations might need replacement rather than mere refinement, that approaches treated as established knowledge might require significant revision, that problems previously considered effectively solved might actually contain unrecognized complexities requiring entirely new analytical tools. Scientific method provides procedural safeguards for managing this tension, for holding models accountable to evidence rather than preference, for prioritizing empirical results over theoretical elegance or personal investment. But these procedures require constant vigilance against powerful psychological currents pushing toward confirmation bias, toward selective perception that amplifies evidence supporting existing frameworks while minimizing contradictory data, toward tribal loyalty to particular schools of thought with which researchers have affiliated their professional identities and reputations. The universe, meanwhile, remains utterly indifferent to these internal human struggles, to our emotional attachments to particular theories, to our career investments in specific approaches, to our desperate desire for the comfort of certainty in a reality that continually reveals itself as more complex than anticipated. It simply is what it is, operating according to principles that existed long before humans evolved to contemplate them and will continue long after our species has vanished, completely unconcerned with whether we find its behavior comforting or unsettling, simple or complex, comprehensible or stubbornly opaque. If reality proves deeper and more intricate than our models, and it always does, must by definition because models represent simplifications while reality encompasses totality, then certainty was always temporary illusion, comfort always provisional, understanding always subject to revision when the next observation reveals patterns our current frameworks failed to predict. Learning to work productively within this state of permanent uncertainty, to make progress while acknowledging that complete understanding may remain forever beyond reach, to navigate between overconfidence in current models and paralyzing awareness of their limitations, represents perhaps the most important lesson that studying cosmic phenomena teaches. It requires developing tolerance for ambiguity without surrendering to complete relativism, maintaining commitment to rigorous methodology without becoming rigid in its application, pursuing systematic investigation while remaining open to serendipitous discovery, building theoretical frameworks while remembering that all such constructions represent provisional approximations rather than final descriptions of reality. This lesson must be relearned repeatedly by each generation of researchers, because the human mind keeps forgetting, keeps sliding back toward the comfortable but false belief that this time we've figured it all out, that current understanding has finally achieved sufficient completeness that major surprises have become unlikely, that the fundamental principles governing reality have been effectively mapped with only details remaining to be filled in. December 19th serves as reminder that such confidence remains premature, that the universe still contains phenomena that don't fit neatly into established categories, that behave in ways current models don't fully capture, that require explanations not yet developed or perhaps not yet imaginable within current conceptual frameworks. It suggests that humanity remains in the early stages of understanding cosmic processes rather than approaching any final comprehension, that future generations may look back at current models with the same mixture of appreciation for their insights and recognition of their limitations that contemporary researchers feel when reviewing theories from previous centuries, that what appears as solid knowledge today may eventually be recognized as approximation useful within limited domains but inadequate for explaining the full range of phenomena the universe contains. As 3I/Atlas continues its journey out of our solar system, following its hyperbolic trajectory back toward interstellar space along a path that will eventually carry it beyond the gravitational influence of our Sun, it takes with it whatever secrets might explain what happened on December 19th. It moves toward stellar regions we cannot predict with any precision because gravitational influences from stars and other massive objects it will encounter over thousands or millions of years remain unknown and essentially unknowable given current observational capabilities. It recedes gradually from visibility, requiring increasingly powerful instruments and longer exposure times to detect, eventually passing beyond the range where detailed study remains practical with current technology, fading back into the darkness between stars from which it briefly emerged. December 19th itself will pass into archives and databases, will appear in academic papers and conference presentations, will become one entry among many in the growing catalog of observations documenting humanity's early encounters with objects from beyond our solar system. The date will be recorded in tables and timelines and literature reviews chronicling the developmental stages of a scientific discipline still in its infancy, will be cited in papers that build upon or challenge the interpretations currently competing to explain what happened during those crucial hours when something unexpected appeared in the data. Future researchers, perhaps working decades from now with observational tools we cannot yet imagine, with analytical techniques not yet invented, with theoretical frameworks more sophisticated and comprehensive than current approaches, may revisit the archived data from December 19th and extract new meaning from patterns current analysis has missed, may identify significance in features currently dismissed as noise or artifact, may answer questions we don't yet know enough to ask. Or perhaps December 19th will remain permanently suspended in ambiguity, one of those scientific mysteries that never receives definitive resolution because the object departed before sufficient evidence could accumulate, because crucial measurements that might have distinguished between competing interpretations were never taken, because the universe spoke in a language we had not yet learned to translate with sufficient precision. Perhaps it will join other tantalizing anomalies that appear in the historical record of various disciplines, observations that hint at phenomena not fully understood, measurements that don't quite align with theoretical predictions, data points that refuse to fall neatly into established patterns. These persistent mysteries serve their own purpose in the development of scientific understanding, providing constant reminder that current knowledge remains incomplete, that comfortable consensus can mask unresolved questions, that nature retains the capacity to surprise even in seemingly well-explored territory. Regardless of whether future work eventually resolves the specific puzzles of December 19th, the questions it raised will continue echoing forward through time, influencing how researchers approach each subsequent interstellar visitor, shaping protocols and priorities in theoretical investigations for decades. Did December 19th reveal natural behavior that existing models should have predicted but didn't because those models were built on limited experience with a statistically insignificant sample size? Or did it expose gaps in fundamental understanding, properties of interstellar objects that current theories haven't adequately characterized, phenomena that exist outside the parameter space explored by standard models? Perhaps the signal meant exactly what both leading interpretations suggest: natural response versus incomplete understanding, and future observations will eventually determine which explanation better fits the full pattern of evidence once more examples have accumulated, once statistical power increases through larger sample size, once the behavior of many interstellar objects can be compared to identify patterns that remain invisible when examining individual cases in isolation. Or perhaps December 19th meant something else entirely, something that requires conceptual frameworks humanity hasn't yet developed, categories not yet named, questions not yet formulated because current scientific vocabulary remains too limited, too shaped by local experience with objects formed in a single stellar environment to encompass the full range of possibilities represented by visitors from other star systems. The universe does not organize itself for human pedagogical convenience. It does not provide teachers' editions with answers conveniently printed in the back. It does not arrange phenomena in order of increasing complexity to help students progress from simple to sophisticated understanding through carefully graded challenges. It simply exists, unfolding according to principles that may eventually prove comprehensible to sufficiently patient and clever observers willing to set aside comfortable assumptions and follow evidence wherever it leads, or that may ultimately exceed the cognitive capacity of minds evolved to solve very different problems than understanding the behavior of objects that travel between stars. Our brains developed under selection pressures that rewarded accurate tracking of social hierarchies within small groups, precise mapping of local environments containing resources necessary for survival, recognition of patterns in weather and vegetation that might predict food availability or danger. They did not evolve to intuitively grasp quantum mechanics or relativistic effects or the behavior of matter under conditions never encountered in ancestral environments. The cognitive tools we bring to these investigations, our capacity for pattern recognition, for constructing abstract models, for extending understanding through analogy and metaphor, developed to solve problems utterly different from those posed by interstellar objects, operating within constraints that bias perception and reasoning in ways we can identify but never entirely eliminate. December 19th reminds us of these limitations not to discourage investigation but to promote appropriate humility about the provisional nature of all human knowledge, to encourage methodological rigor that compensates for cognitive bias, to maintain openness to possibilities that might initially appear implausible when viewed through frameworks built from limited local experience. Either way, whether December 19th eventually yields to explanation through accumulation of additional evidence, through development of more sophisticated analytical techniques, through construction of more comprehensive theoretical frameworks, or whether it remains permanently suspended in ambiguity, the universe continues its operations completely indifferent to human interpretive struggles. It follows laws that were ancient before Earth coalesced from its protoplanetary disk, that govern the formation of galaxies and stars and planets long before the first organic molecules began the chemical processes that would eventually lead to life, that will persist unchanged long after humanity either expands beyond its birth world to become something capable of long-term survival within the wider cosmos or follows the path of countless other species into extinction, leaving no trace that conscious observers once briefly existed in this particular corner of a galaxy containing hundreds of billions of stars. In that vast cosmic indifference, in that incomprehensible scale that measures time in billions of years and distances in millions of light years, that thinks nothing of waiting eons for processes to complete or of maintaining conditions lethal to all known forms of life across regions larger than entire planetary systems. December 19th represents nothing. It marks a brief moment when human attention focused on one small object passing through one unremarkable stellar system in an outer spiral arm of a galaxy containing more stars than there are neurons in a human brain. The object itself will continue its journey whether observed or not, will pass through regions of space no human instrument will ever directly examine, will eventually approach other stars that might or might not harbor planets where observers might or might not exist to detect its passage. It carries no message except what can be inferred from its composition and trajectory, contains no purpose beyond what physical law has determined through billions of years of gravitational interaction, holds no intention toward the brief moment when it passed close enough to Earth for human instruments to detect the subtle anomalies that appeared on December 19th. And yet for those who exist in this particular moment of cosmic history, who were watching when something subtle shifted in the data streams flowing from observatories, who felt the quiet weight of questions that resist easy resolution, who experienced that strange mixture of excitement and unease that comes from realizing the universe has shown us something we don't fully understand, December 19th is everything. It represents the reminder that reality still contains mysteries, that humanity remains in early stages of comprehension rather than approaching any final understanding, that the cosmos will continue surprising us for as long as we maintain the wisdom to keep watching and the humility to accept those surprises as gifts rather than threats, as opportunities for expanded understanding rather than uncomfortable challenges to established knowledge. December 19th provides evidence that discoveries await those patient enough to observe carefully, that phenomena exist beyond what current theories predict, that reality contains depths and subtleties that reveal themselves only to minds prepared to recognize significance in unexpected patterns. It confirms that there are still moments when the universe can make experienced researchers pause and reconsider frameworks they believed settled, can force recalibration of understanding that had calcified into certainty, can generate the particular intellectual excitement that comes not from confirming what was already suspected but from encountering something genuinely unexpected, something that expands rather than merely reinforces existing knowledge. The future into which 3i/Atlas moves, carrying whatever secrets might explain what happened on December 19th, represents a region of spacetime that remains forever inaccessible to current human observation. The object travels toward stellar neighborhoods we can catalog but never visit, toward potential encounters with other planetary systems that will occur millions of years after current civilizations have transformed beyond recognition or disappeared entirely, toward futures that exist beyond the horizon of prediction given the chaotic nature of gravitational interactions across cosmic timescales. This future remains mathematically determined by initial conditions and the laws of physics but practically unknowable due to sensitivity to unmeasurable precision in starting parameters, to cumulative effects of encounters too distant to detect, to the fundamental limits of prediction when dealing with complex systems over extended timescales. This unknowable future into which 3i/Atlas disappears mirrors the future toward which humanity itself moves, blind to what waits ahead in times not yet experienced, subject to forces larger than individual or collective human intention, carrying information about origins whether conscious of doing so or not, whether such information will ever be recognized or interpreted by any future intelligence. Both object and observers move along trajectories shaped by forces operating across timescales that dwarf individual human lifespans, both influenced by initial conditions established long before current configurations emerged, both subject to laws that operate with complete indifference to whether their operations are understood or their consequences desired. Perhaps, though this represents speculation rather than science, though it extends beyond what evidence currently justifies, somewhere in the vast silence between stars, in the darkness where signals might travel for millions of years before reaching any potential receiver, the universe itself watches. Not with consciousness that resembles anything we would recognize as mind. Not with intention or curiosity that mirrors human attributes. Not with purpose that aligns with concepts like meaning or value as human cultures construct them. But watches in the sense that physical law records everything, that information about interactions is never truly lost but merely transformed, that every event leaves traces that propagate outward through spacetime whether or not any observer ever reconstructs their meaning. In this metaphorical sense, the universe waits with infinite patience. The patience of something for which time as humans experience it has no meaning, for which a billion years passes with the same indifference as a nanosecond, for which waiting represents not subjective experience but merely the playing out of causal chains established at the moment of cosmic origin. It waits to see if humanity will develop the observational tools necessary to detect the subtle signals it has been transmitting all along in the language of physics, if we will construct theoretical frameworks sophisticated enough to translate those signals into understanding, if we will grow wise enough to recognize that every answer reveals deeper questions beneath, that knowledge represents not destination but journey continuing for as long as minds capable of inquiry exist to undertake it. December 19 asked one such question, whispered it in the slight irregularities of a light curve that should have followed predicted patterns but didn't, in orbital residuals that persisted despite repeated refinement of calculations, in spectroscopic features that appeared and disappeared on timescales models couldn't explain, in the clustering of anomalies around a date that should have passed unmarked in the observational record. This question remains suspended in the data, unanswered and perhaps unanswerable with current capabilities, perhaps requiring decades more observation of additional interstellar visitors before we can even be certain we're framing it correctly, before we accumulate enough examples to distinguish between normal behavior for objects of this class and genuine anomaly, before we develop theoretical frameworks that adequately capture the full range of possibilities represented by objects that travel between stars. We continue listening for answers that may never come, continue watching for patterns that might illuminate what happened on December 19, continue developing observational techniques and analytical methods and theoretical models that might eventually transform mystery into understanding. And in that listening, in that patient attention sustained despite uncertainty, in that willingness to hold questions open when they resist easy resolution, in that commitment to investigation that continues even when results remain ambiguous, we become something slightly more than we were before encountering the puzzle December 19 presented. Not necessarily wiser in any dramatically transformative sense. Not fundamentally changed in our basic nature. But perhaps more aware of our limitations, more humble about the provisional nature of knowledge, more patient with the sometimes glacial pace at which the universe reveals its secrets to those with courage enough to keep asking questions when answers remain elusive. In the quiet hours of observatories scattered across our planet, where researchers maintain their vigil of the night sky, instruments continue gathering photons that left distant objects years or decades or centuries or millennia ago, that traveled across unimaginable distances carrying information about events no human witnessed directly, that reveal conditions and places no human will ever physically visit. The data accumulates in storage systems distributed across continents, terabytes expanding to petabytes expanding to exabytes, an ever-growing archive of humanity's systematic observation of the cosmos surrounding our small world. Within this vast collection, the records of December 19 represent a minuscule fraction, a few gigabytes among quintillions of bits, data points that would appear entirely unremarkable if not for the subtle patterns they contain, the deviations from expectation they record, the questions they raise about objects that travel between stars. These questions will outlive the particular researchers who first noticed the anomalies, who developed the competing interpretations currently vying to explain what happened, who designed the observational campaigns attempting to gather additional evidence. They will pass to future generations who might approach them with instruments not yet built, with analytical techniques not yet developed, with theoretical frameworks not yet formulated. They will remain open for as long as they resist definitive resolution, for as long as the universe withholds the additional evidence that might distinguish conclusively between competing explanations, for as long as interstellar objects remain sufficiently rare that statistical patterns cannot yet emerge from the limited sample available for study. In this persistence through time, in this passing of unresolved questions from one generation of investigators to the next, in this accumulation of partial understanding that gradually approaches but perhaps never reaches complete explanation, December 19 participates in the oldest and most fundamental human intellectual tradition. From the earliest moments when our ancestors looked toward the night sky and wondered about the nature of the lights they saw moving among the fixed stars, humanity has been asking questions about cosmic phenomena that individual questioners would not live long enough to see answered, has been building understanding through contributions that span lifetimes, has been maintaining investigation across generations connected by shared curiosity about the universe that surrounds us. December 19 takes its place within this tradition, adding its particular mysteries to the catalog of questions humanity continues exploring, contributing its specific puzzles to the ongoing investigation of reality that represents perhaps our species' most distinctive and valuable collective enterprise. Some dates mark endings, the conclusion of processes, the resolution of questions, the completion of journeys. December 19th marked the beginning of a question that may outlive us all. A question whispered in the language of subtle anomalies, of deviations from expected patterns, of behaviors that resist explanation within current frameworks. A question that reminds us how much remains unknown about objects that travel between stars, about processes that unfold across millions of years, about phenomena that exist at the boundaries of current understanding. A question that may eventually find answer through patient observation and theoretical development, or that may remain permanently suspended in the ambiguity that characterizes so many aspects of humanity's encounter with a universe larger and more complex than minds evolved on a single planet can fully comprehend. In the deep silence of interstellar space, as 3I/Atlas continues its eternal journey between stars, the mystery of December 19th remains encoded in its structure, in its composition, in properties we glimpsed only briefly during its passage through our solar system. Perhaps future civilizations, whether human descendants or intelligences that evolve on worlds we will never know, will someday possess the capabilities to resolve questions we can currently only formulate. Perhaps the answers exist, waiting patiently for observers clever enough to recognize them, for instruments sensitive enough to detect them, for theories comprehensive enough to explain them. Or perhaps some mysteries represent fundamental limits of knowledge itself, questions that resist final resolution not through temporary technological limitations but through deeper constraints on what finite minds can comprehend about an effectively infinite reality. Either way, December 19th has already performed its most important function. Not providing answers but prompting better questions, not delivering certainty but inspiring sustained curiosity, not confirming what we thought we knew but reminding us how much remains to be discovered about the universe we inhabit. It has joined the constellation of dates that mark moments when humanity glimpsed something unexpected about cosmic reality, when the universe revealed itself as more complex or subtle or mysterious than current understanding had acknowledged, when the boundary between known and unknown shifted slightly but significantly. In the vast cosmic calendar that stretches across billions of years, December 19th represents an infinitesimal point, a moment so brief as to be effectively instantaneous, a flicker of attention paid by a species that itself represents the merest eye blink in the history of a universe that was ancient before the first star ignited and will continue long after the last stellar ember fades to darkness. And yet, within the more limited time frame of human experience, December 19th may eventually be recognized as one of those pivotal moments when understanding took a small but crucial step forward, not through dramatic breakthrough but through the recognition that existing frameworks required expansion, that comfortable assumptions needed reconsideration, that the universe had whispered something not yet fully understood but potentially significant about the nature of objects that travel between stars. This recognition represents not endpoint but beginning, not conclusion but invitation to deeper investigation, not final statement but opening question in a conversation with reality that continues as long as curious minds exist to participate. The universe whispered something on December 19th. We're still learning how to listen.